Hello, this is Mr. Collier, and today we're using Euler's method to find approximate solutions to differential equations. Okay, so Euler's method is basically like this. If you're given a differential equation, you basically have a function for giving you slopes and not the original function. So if you're at a certain point, you can estimate the solution. If you have an initial value, you can estimate a solution that's away from the initial value by taking your slope and kind of extrapolating with a linear function. Okay, if you do that with a smaller size h, smaller step size, you get a more accurate answer. Okay, so you can use your differential equation to generate the slope and estimate where the next point's going to be, and then you use the slope here and estimate again. So you get closer and closer to the curve if you take smaller and smaller step sizes. So that's basically how it works, and here's the formula from the formula booklet. The yn plus 1, that means like the next y is always the previous y, plus the step size times, this is basically your slope when you plug it into your differential equation. Okay, so I'll show you what I'm talking about here. This is the differential equation, and this is what you're trying to estimate. You're trying to estimate f of 1 basically. Okay, and you're starting off the initial value 0, 1. So let's start off with that. We're going to make a table. Your initial values are 0, 1. Then here's your dy dx, which is basically your slope. We're going to evaluate each time, and we're going to step it up 0.25 each time. So we're going to have 0.25, 0.5, 0.75, and then we're going to get 1. Okay, next we'll get the slope here. So we just substitute in 0 and 1, and we get a 1 here for the slope. Now to get the new y value, that's where we use the formula. So yn plus 1 equals the previous y value plus the slope times h, or h times the slope, either way. So it's 1.25 is your new y value. Okay, then to get your slope again, your dy dx, or your slope, you do the previous y value, which is just plug it into this equation right here. So slope is going to be 0.25 minus 1.25 squared plus 2. This kind of stuff is better done with a calculator. So 0.25 minus 1.25 squared plus 2 is 0.6875. Okay, and then to get your next y value, you'd use this formula again, right? To get your next y value, you get your previous y value, which is 1.25, plus the step value, which is 0.25, times your slope, which is 0.6875. So let's do that. We do 1.25 plus 0.25 times, and you can go up and copy your answer from before. And we got 1.421875. 1.42, I'll just write that down in the table. Okay, so next we get our new slope. So we gotta do the old x value, which is or the new x value, 0.5, minus y squared, which is our answer from before, squared, plus 2. Okay, that gives us 0.7478-ish. Alright, then we get our new y value, so we do our previous y value, which is up here. Then we subtract, we add our step size times our slope from before, which is that one. Oops, that there should give me 1.54. Okay, so then we do that again, or we get the slope again, so it's going to be the x value, which is 0.75 minus the y value squared, so let's copy that, square it, plus 2. Okay, this one use slope 0.373. And lastly, this is going to be your answer, so we just have one more step to go. We take our previous y value, which is up here, plus the step size times your slope from before, which is right there, and you get 1.63 to 3 significant figures.